So I'll be giving this assignment today, but I'll be doing few problems. Okay. I suggest everyone to try it sincerely because you will definitely get a problem from this. So just to recollect, condition for bright fringes, path difference is n lambda. For dark fringe, did you observe they've given 2n minus lambda by 2? But you can use 2n plus 1 also. That's up to you. So distance of the nth bright fringe from the center is n into lambda into capital D by D. So x n dash, the distance of the nth dark fringe from the center is 2n minus 1 into lambda into capital D by 2D. Fringe width is lambda into capital D by D. Then lambda is equal to beta D by capital D. Okay. So one advantage of doing this experiment is we can actually find out the wavelength of the light, because fringe width, you can see it on the screen. I told you, no, you will be able to see the bright spot and the dark spot. You take a small scale, you can measure the distance between them. Similarly, from the screen, that is the example of cardboard, okay? From the cardboard to the screen, you can measure the distance. On the cardboard, can you measure the distance between the two holes? So all these distances can be easily measured. So since you have a mathematical formula which is readily available, if you substitute every value in that, you will get the wavelength of the monochromatic light that you're using. You can actually see it as an application also, but nowhere it is spoken. But you can take it as an application of Young's double slit experiment. See, if you ask me why Young's double slit experiment was done, it was done to prove the wave theory of light. Okay, but out of that, an unexpected output is you can find the wavelength also. So this angular width and all you need not worry about. I will tell when time comes. So these are all the points that are mainly required for CBSE. Okay. So let's do the first problem. If there is any doubt, let me know. So in Young's double slit experiment, the two parallel slits are made 1 millimeter apart. So the distance between the slits is what? Small d. So how much is that? 10 power minus 3 meter. They've given it as 1 millimeter. And the screen is placed 1 meter away. Capital D is how much, guys? 1 meter. What is the fringe separation when blue-green light of wavelength 500 nanometer is used? See, since two colors are used, you may not worry about whether it is monochromatic or something. Just go with it. 500 nanometer. It is actually a mix of these two colors. Okay. So wavelength is how much? 500 nanometer. I think it's a very simple problem. What are we supposed to do? Beta is equal to, fringe separation is fringe width. Beta is equal to lambda into capital T divided by small d, that is 500 into 10 power minus 9 into capital D is 1 divided by 10 power minus 3. So how much will it be? 500 into 10 power minus 6 meter, or there's going to be 5 into 10 power minus 3 meter. 5 then.
minus
0.5.
4.
0.5. 0.5 into 10 power minus 3. 0.5. So 0.5 into 10 power minus 3 meter is 1 millimeter. Okay. So some more important points is, see, in this question they have asked fringe width, but in different questions they might ask you different parameters, right? If suppose the question is related to small d, they're asking you to find the distance between the slits, report the answer in terms of millimeter. Okay, please make a note of it. If the distance of separation between slits is asked, report the answer in millimeter. If the distance between the screen and the slit is asked, report it in terms of meter. If fringe width is asked, report it in terms of millimeter, or sometimes meter is also accepted. I'm not saying it is not accepted, but that's the standard format. Okay. Similarly, if wavelength is asked, report the answer either in terms of nanometer or angstrom. So nanometer is 10 power minus 9 meter, angstrom is 10 power minus 10 meter. Okay. So these are all some important points. Shall I move on to the next one?
Yes, sir.
See, don't write the question, okay? Yeah, I'll be uploading this assignment today after the class.
Yes, sir.
Okay, and proceeding to the next. So the second question is laser light of wavelength 630 nanometer. Okay, wavelength is given. How much is it? 630 nanometer. That is 630 into 10 power minus 9 meter. I did this conversion only for the solving purpose. Incident on a pair of slits produces an interference pattern in which the bright fringes are separated by 8.1 millimeter. So beta is 8.1 millimeter. A second light produces an interference pattern in which the fringes are separated by 7.2 millimeter. Calculate the wavelength of second light. So one important point to be noted here is the setup is the same. The distance between the slits is the same, and the distance between the slit and the screen is also the same. But what is changed?
Lambda.
The colors are changed, right? So two scenarios should be taken: lambda 1, beta 1. Okay. So observe this. Beta 1 is how much? I'm going with the formula. Beta 1 is equal to lambda into capital D divided by small d. Only changes lambda 1 into capital D divided by small d. Let this be equation number 1. What about beta 2, guys? Lambda 2 into capital D divided by small d. Let this be 2. Beta 2 is also given. How much is it? It is 7.2 millimeter. Correct? So beta 1 divided by beta 2 will be equal to, can I write it as lambda 1 by lambda 2, which implies, so what is beta 1? 8.1. It is in millimeters, so I'm not converting. 7.3. Lambda 1 in this problem, leave it in nanometer. Lambda 2 will be how much? 8.3 and 7.2. Both are multiples of 9. This will go 9 times. This will go 8 times. So this will go 70 times. So lambda 2 is how much, guys? 560 nanometer.
Five.
How to verify your yes? How to verify your answer is right or wrong? It's by looking at the fringe width. So one thing is clear from this question, that beta is directly proportional to lambda. Correct? Because capital D by small d is constant in both the cases. So beta is directly proportional to lambda. Since the distance between since the fringe width has got decreased, wavelength also should have got decreased compared to the initial case. So initially it was 630, now it is 560. Yes. If at all you get the value greater than 630 or not. Suppose if this question comes in MCQ, you need not sit and solve it. Or if at all the options are in such a way that 3 options are greater than 630 and 1 is less than 630, you can directly go with that option. That's why I mentioned it. Okay.